There are two more set operations that are especially useful and definitely worth knowing about. And the first of these is the power set. The power set is an operation that takes as input a single set that I'll call A. And we write the power set different kinds of notation, but often we write it fancy P of A. And what fancy P of A, the power set of A, what that is, it's the set of all subsets of A, including A itself. So this sounds a little abstract, but let's jump right into an example. So let's do this example here. So I'm going to choose A to be the set 0 and 1. So A has two elements. To compute the power set of A, we need to look at all possible subsets of A and collect them in a big set. So I'm going to write my fancy P of A. Fancy P of A, it's a set, so I'm going to start with some big set braces there. And what's inside the set is more sets. Everything inside fancy P of A is a set. So here's one subset of A. That's the set containing simply the element 1. Here's another one, the set containing simply the element 0. And then here's two more sets that are easy to forget, but also importantly belong in the power set. The first of these is the entire set A itself. So that's the set 0, 1. And that's the set A. And then the final set, easy to forget, is the empty set, the set containing no elements at all. And that's the set that we denote with the circle with a slash through it. And all of this is inside a set. So let's do a little bit of counting here. The power set of A has 1, 2, 3, 4 elements inside it. It's important to keep in mind that these elements are all sets. None of the individual elements of A are ever elements of the power set. So for example, 1 is not an element of the power set of A, even though 1 is an element of A itself. Instead, what's true is that the set containing 1 is an element of the power set of A. So the individual elements of A are never elements of the power set. Instead, the sets containing elements of A are elements of the power set. One note about power sets that is interesting and which we'll learn to prove later in these videos is that if you ask about the cardinality of the power set, the cardinality of the power set has a formula. It's equal to 2 raised to the power of the cardinality of A itself. So in this example, the cardinality of A, well, the number of elements in A was 2 elements, 0 and 1. So in this example, the cardinality of A is 2, and therefore the power set of A has cardinality 2 raised to the 2 power, which is 4. And indeed, that matches what we saw in our example. So the power set is the set of all possible subsets of a given set A, and we use this in order to speak about different subsets of A. So if we want to think about subsets that have a certain property, those are elements of the power set. Another useful set operation is the Cartesian product. So the Cartesian product is an operator that takes in two sets that we'll call A and B. And what the Cartesian product does, we write it this way, A times B. The Cartesian product looks at tuples, so pairs of elements where the first entry is an element of A and the second entry is an element of B. So let's do an example of the Cartesian product. So let's do A is the set 0, 1, and B can be the set A, B, C. Or just think of those as letters. So here, if we want to form the Cartesian product, so A times B, A Cartesian product B, the Cartesian product is going to hold a bunch of pairs of elements where the first entry of the pair comes from A and the second entry comes from B. So for the first element, for example, I'll choose a 0 from A and a little a from B. I can choose a 0 from A and a little b from B. I can choose a 0 from A and a little c from B. And then I can do all the same, except where I choose 1 instead of 0, 1 and B, and then 1 and C. And then I close this off with my curly braces. So here, everything inside the Cartesian product, it's not an element of A, it's not an element of B, it's a pair of things. It's a tuple, if you will, a two-tuple. There's also a nice formula for the cardinality of the Cartesian product. The cardinality of the Cartesian product of A and B is, and this one is a little easier to remember, it's simply the product of the cardinality of A times the cardinality of B. So if we look here, we say, okay, A has 2 elements and B has 3 elements. 2 times 3 is 6. And if I check the number of elements in A times B, 1, 2, 3, 4, 5, 6. So I can see that in this example, my formula checks out.